Okay, I found this linear queue, which is quite a good example. Let's watch this together. Yeah?
Welcome back, everyone. So we're going to implement a linear queue using an array. So let's get started. Now, before I move on to what is a queue, please don't forget to like, subscribe, and most importantly, click that notification bell if you enjoyed this video. So what is a queue? So a queue is simply a linear data structure that supports FIFO operations. And linear means that items can be added sequentially to the queue and removed sequentially from the queue. And FIFO stands for first in, first out. And all that says is that the first element we add to our queue is the first element we remove from our queue. And I like to think of a queue as a line in your favorite fast food restaurant. So picture you're in line, and you're the first person in line. If you're the first person in line, you're the first person who's going to be served and the first person to leave. So that's basically the same thing here. The first element in line is going to be the first element to leave that line, and that's how a queue works. The last element in line is also going to be the last element that leaves that line or that queue. So let's move on to the enqueue operation. Now, to enqueue an element is the same thing as add an element to the rear of my queue. Now, unlike a stack where I add to the top and remove from the top, so I only need to keep track of one variable, in a queue, because I add to the rear and remove from the front, I need to keep track of those two things. Initially, I'm going to set my front and rear to -1 to represent that I have no elements currently in my queue. At the point where I add my very first element to my queue, I'm going to set my front and rear both to index 0, since the front element is going to be at index 0 and also my rear element is going to be at index 0, since we only have one element in our queue. At the point where I add another element to my queue, I only increment my rear by a single index. And I keep doing so until I've added all the elements I need to add to my queue. Now, let's look at the dequeue operation. So there are two ways we can think about this. We can be more time efficient and less space efficient, or more space efficient and less time efficient. If we were to go with the more space efficient route, what we can do is every time we remove an element from the front of our queue, we can shift the remaining elements to the left. So every time we remove a single element, it'll be O of n time complexity. Now, if we were to dequeue all the elements in the queue, that would be very, very time costly, resulting in a big O of n squared time complexity. Now, the way I'm going to do this is to be more time efficient, but less space efficient. So every time I remove an element from my queue, I'm just going to increment my front by one index. So it'll simply hold the next element in line. And we can keep performing this action. Now, we can see how much space is being wasted. If I wanted to add an element to my queue, my rear will go up by one index. So my rear will be set to index 5, and my front remains at index 4. So we've essentially wasted spaces 0, 1, 2, and 3. So we can see how this becomes very, very space inefficient. Now, there's a better approach known as a circular queue, which we'll learn about later on. As for now, if you wanted to dequeue the last element in this queue, all we do is set our front and rear back to -1, since we have no elements currently in our queue. Now, let's look at the common operations associated with the queue. I'm going to cover 5 common operations: enqueue, dequeue, peek, is empty, and is full. Now, before we get to those methods, let's see what the actual class structure of a linear queue looks like. So here I have 3 instance variables: front, rear, and a nums reference variable. The front is going to keep track of the front of my queue. The rear is going to keep track of the rear of my queue. I'm going to use an int array to represent my queue. Now, in my constructor, I'm going to take in a size which is going to be used to represent the maximum size of my queue. I initialize my front and rear instance variables to -1, and I also initialized my nums reference variable with a new array object of that size. Now, let's look at the enqueue method. So I'm going to take in some arguments data, which will be used to add to my queue. The first thing I want to do is check if my queue is full. If my queue is full, which means there's no more space for me to add anything to my queue, I'm simply going to throw a new illegal state exception to indicate just that. However, in this case, my queue is not full, so I'll simply move on to my next if block. So in here, I check if my queue is empty. Now, the reason I want to do that is because, as we remember, our empty queue, our front and rear will both be set to -1. So I'd want to increment my front to index 0 to represent my first element in my queue. However, in this case, because it's not empty, I simply just have to increment my rear by 1 index and insert my data at that position. Now, let's look at the DQ method. So the first thing I want to do in this method is check if my queue is empty, because if my queue is empty, then that means there are no elements for me to remove. So I'll simply throw a new no such element exception to indicate that I have no elements to remove in my queue. However, in this case, my queue is not empty. So the next thing I want to do is to be able to store that data associated at the front index in my queue, since I want to be able to return that data. So I'll simply store that data in a variable called temp. Now the next thing I want to do is check if my front is equal to my rear. Now if my front is equal to my rear, that would mean I have exactly one element in my queue. And for me to remove that element, all I can do is set my front and rear both back to -1. However, in this case, my front is not equal to my rear, so I'll simply move on to my else. So like we've seen before with the animation, my front will increment by 1 index. And then all I have to do at this point is return that temp data that I stored. Now, let's look at the peek method. So this method is pretty straightforward. If my queue is empty, I'll simply throw a new no such element exception to indicate that I have no elements currently in my queue. However, in this case, my queue is not empty. So I'll simply return the data associated with the front index in my queue. Now, let's move on to the empty method. So my empty method is also very simple. All I want to do is return whether or not my front is equal to -1. Now we can also do a check if our rear is equal to -1, because as we know, both our front and rear will be set to -1 if we have an empty queue. So here I just did a check to check if my front is equal to -1. If my front is equal to -1, I'll return true. If my front is not equal to -1, I'll return false. In this case, I'll simply return false. Now let's look at the full method. So in our full method, it's also very simple. Because our rear variable holds the index of the last element we add to our queue, if our rear is equal to nums.length -1, then it would mean that our queue is full. So we'll simply return true if that's the case. However, in this case, our rear is not equal to nums.length -1, or in this case 5, so we'll simply return false. Now let's look at the complexity analysis. So for our time complexity, since our NQ and DQ methods add an element to the rear of our queue and remove an element from the front of our queue respectively, we're going to use a constant number of operations. Now the number of operations we're using is also independent of the size of the array. So it remains the same regardless of the size of our array. That's why it's constant time. For our peek is empty and is full methods, they're all going to use a constant number of operations, since the number of operations they use are going to be independent of the size of our array. Moving on to the space complexity, for NQ, DQ, peek is empty and is full, we're all using a constant amount of space independent of the size of the array. And we're not resizing this queue, so that's going to mean that we're not going to use any extra space if we have to transfer those elements over. Now, keep in mind how much space we're actually wasting by implementing a linear queue using an array. And we'll see a much better implementation of that known as a circular queue later on, so definitely stay tuned for that. If you enjoyed this content, please hit that like and subscribe button. See you in the next video.
Okay, that's linear queue. Now we have gone through some of the slides. I'm not going to go and touch on that one. Yeah, we're going to move on to the next slide. Yeah. Okay, this one is linear array with dynamic run. So basically, I found a video that states about static arrays versus dynamic arrays. And I found it's quite interesting, which pretty much sum up the whole thing. So again, another video which I found is circular queue, which also clearly explain about what is a circular queue, which is here. Okay. All right. So just now we managed to reach until pretty much all right, almost, but we haven't really just watched the video, I think. Okay. So you can sum up and we can get on with our practical.
Welcome to CodeFight's interview practice. In this video, we will review one of the simplest data structures, the array. Arrays are used to store variables, and the information is indexed to allow easy lookup. In this array, we would say the yellow marble is at index 2. By knowing where the array starts in memory and the size of each individual variable, it is easy to use the index to find the variable immediately. If we want to check the color of the marble at index 3, say, we can start at the beginning of the array, move down 3 Welcome to CodeFight's interview practice. In this video, we will review one of the simplest data structures, the array. Arrays are used to store variables, and the information is indexed to allow easy lookup. In this array, we would say the yellow marble is at index 2. By knowing where the array starts in memory and the size of each individual variable, it is easy to use the index to find the variable immediately. If we want to check the color of the marble at index 3, say, we can start at the beginning of the array, move down 3 spaces, and discover that the marble with index 3 is blue. It is important to distinguish the difference between accessing an element by index and trying to find a specific element. We have already seen that checking the color of the marble at index 3 is fast, but to try and find a blue marble in the array requires going through the array one element at a time. The simplest type of array is a static array. As the name suggests, their size cannot be changed. Because of this, we cannot directly add an element to a static array. We can achieve the same effect by making space for a larger array, creating the new array, copying elements over from the old array, and then deleting the old array. Deleting an element is the same process in reverse. First, we make space for the smaller array, create the new array, copy the desired elements over, and delete the previous array. If we are frequently adding or removing items from an array, our program can spend a lot of time copying elements between arrays in memory. A dynamic array is one way of addressing this issue. A dynamic array reserves a larger amount of space than it needs, while also storing its size. When we want to add an element, if there's space, we can put the element in while increasing the size parameter. If we want to delete an element, we can remove it while decreasing the size parameter. Of course, if we add too many elements, we can still run out of room, and we have to increase the size of the dynamic array. This involves the same copying process as a static array. The advantage is that we don't have to undergo this process every time we change the number of elements, only when we run out of room, or when we are worried we are using too much space. The advantage of using a static array is that we only use as much memory as we need. The advantage of a dynamic array is that we're able to add and remove elements quickly. Be sure to check out CodeFight's interview practice for more information about arrays and to practice solving real
Or the dynamic,
Okay, let's-
dynamic array can still become bigger.
Yeah,
Okay.
so the static and dynamic. Okay, this is a very simple explanation on how your static and dynamic. Now you see how they change places, right? You can expand the size of the array. There's a code for that as well. Okay, so this is front index dynamic, back index initialized to -1, just like the video is explaining. So if this is NQ, doing it very quickly. Yeah, this one, as mentioned just now, it's fast, and then dynamic one, it's basically, yeah, it's fast, right? But there'll be a lot of space. What to use for the empty locations. Now, next one is the circular array.
Hello everyone,
Hello
so we're going to
everyone, so we're
implement
going
a
to implement a
dynamic circular queue using an array.
using an array.
So let's get started. Now, before we get to what is a queue, if you enjoyed this content, please don't forget to like, subscribe, and most importantly, click that notification bell for updates. Now, I definitely recommend that you check out my video on how to implement a linear queue using an array, as it'll give you a better understanding of why we're implementing a circular queue using an array in the first place. So, what is a queue? A queue is simply a linear data structure that supports FIFO operations. And linear means that you can add items and remove items sequentially from the queue. And FIFO stands for first in, first out. And all that means is that the first item that you add to the queue is the first item that you remove from the queue. Similarly, the last item that you add to the queue is going to be the last item that you remove from the queue. Now, let's look at the enqueue method. Now, as we've seen with the linear queue, the problem that we faced was that we either used too much space or we used too much time. And to combat this, we're going to use the idea of wrapping elements back around as if they were in a circle, thereby reducing our space consumption that we've seen with a linear queue. So just like a linear queue, my front and rear are going to be set to -1 to represent that I have no elements currently in my queue. At the point where I add my very first element to my queue, I'm going to set both my front and rear to index 0, since my front element and my rear element are going to be the same exact element. Now, with a circular queue, we cannot just increment our rear by a single index, like we've seen with a linear queue. And the reason for this is because picture our rear was at index 5, and we want to insert another element. Then, using the idea of rear plus 1 would give us an index of 6, which does not exist in our array. So we have to find another way to combat this. And if we think about this carefully, our 5 plus 1 is going to give us a value of 6. And the remainder from 6 divided by 6 is going to be 0, which is the next index in the array. So we can effectively use this idea or this calculation of rear plus 1 modulo length to give us the next index in the array. Now, this clearly works with any other index in the array as well, because as we know, every index is going to be less than the length of the array. So that means when that index is divided by 6, we're going to get that index as a remainder. Now let's take a look at some enqueue operations. If you want to enqueue an element, our next position is going to be 1 modulo 6, or at index 1. Then our next position is going to be 2 modulo 6, or index 2. And our next position is going to be 3 modulo 6, or index 3. And so on and so forth. Now, at the point where our index is 5, since we're enqueuing in a clockwise direction, at the point where our rear plus 1 is going to equal to our front index, then we know we have a full queue. So now let's look at the dequeue method. So as we've seen with our enqueue method, to get the next index, all we do is take that current index, add 1, and then modulo the length of the array. And that same concept that's in the calculation clearly applies to the front variable. All we're doing is using another variable. So to set our front to the next index in the queue, all we do is take our front plus 1 and then modulo length. So we'll get 1 modulo 6, which is going to give us a value or index of 1. And we do the same thing to get the index of 2, and the same thing to get the index of 3. Now let's look at some more enqueue operations to show you that circular process. So here our rear is at the last index in the array. And as we know, to get the next index, all we do is take our 5 plus 1 and then divide it by 6 and use that remainder. So that's going to be 6 divided by 6, which gives us a remainder of 0. So our next index is going to be 0. And the same process applies for every single index. Now, as we've seen before, at the point where our rear plus 1 modulo length gives us the front index, then we know we've filled our entire array and we have no more space. Now, let's look at the common operations associated with queue. Here I'm going to cover 6 common operations: enqueue, dequeue, peek, is empty, is full, and resize. Now, my is full and resize methods are going to be helper methods. Now, before we get to those methods, let's see what the actual class structure of a circular queue looks like. So if you've seen my video on how to implement a linear queue using an array, you may notice that this is the exact same class structure as my linear queue. And that's because it is. The only things that change are going to be the way that we enqueue and dequeue. So here we have 3 instance variables: front, rear, and a nums reference variable. Our front is going to keep track of the front of our queue, and the rear is going to keep track of the rear of our queue. Our nums are going to be an int array that's going to represent our queue. In our constructor, we're going to take in an initial size, which is going to be used to represent the initial size of our queue before we resize. We're also going to initialize our front and rear to -1 since our queue is empty. Now let's look at the enqueue method. So in our enqueue method, we're going to take an arguments data and use that data to add to our queue. So the first thing we want to do is check if our queue is full, because if our queue is full, then we'll have to resize our queue. However, in this case, our queue is not full. So we simply move on to our else if. So now we want to check if our queue is empty, because as we know, an empty queue would mean that our front and rear are both set to -1. So we'd have to increment both our front and rear to represent that we've added our first element to our queue. However, in this case, our queue is not empty. So we'll simply perform that same calculation like we did in the illustration. We'll set our rear equal to rear plus 1 modulo num.length, which is going to give us the index of 1. At that point, we simply insert our data at that position. Now, so in our DQ method, the first thing that we want to do is check if our queue is empty, because if our queue is empty, then that means that there are no elements to do to be able to store the data to return it. Then we want to make sure to check if our front is equal to our rear. Because if our front is equal to our rear, then it means that we have exactly one element in our queue, and then we can set both our front and rear back to -1. Front plus 1 modulo num. Get that thing. So our in my queue empty data associated with the index in our queue. So now let's look at the empty method. Our empty method is just as simple. So all we have to do is check if our front. However, in this case, our front is not equal to our rear. So we move on to our else. Now, as we've seen before, to get the next element in the queue, we're going to have to set our front equal to front.
Okay now?
Oh yeah, okay now.
Yeah.
Plus 1 modulo nums.length. Again, that same calculation. So we've set our front to index 4. And then we simply return our data at index 3. Now, let's look at the peek method. So our peek method is very simple. The first thing we want to do is check if our queue is empty. Because if our queue is empty, then we can simply throw a new no such element exception to indicate that there are no elements currently in my queue. However, in this case, our queue is not empty. So we'll simply return the data associated with the front index in our queue. So now let's look at the empty method. Our empty method is just as simple. So all we have to do is check if our front is equal to -1, or even our rear is equal to -1. Because as we know, if our queue is empty, both our front and rear will be set to -1. However, in this case, my front is not equal to -1, so I'll simply return false. Now our isFull method is just as simple. Because as we've seen with the animation, if my next index is equal to the front index, then that means that I have a full queue. So in that case, if my rear plus 1 modulo my nums.length is equal to my front index, then I'll simply return true. However, in this case, I'll simply return false. Now let's look at the resize method. So there's a bit more code here, but as we go through it, you'll see how simple it is. So the first thing I want to do is double the size of my queue if my queue is full. So I'll simply create a new array object of size nums.length multiplied by 2. Now, because I'm copying all the elements from my old queue to my new queue, I'm going to need a variable to keep track of where I am in my new queue, as well as a variable to keep track of where I am in my old queue. So I'll use my variable I here to traverse my new queue. And I'll set j equal to front that will be used to traverse my old queue. I'm going to set it to the front of my queue because that's where my queue begins. Now, as we've seen with most circular structures, it's a really good idea to approach this using a do-while loop, because my front is my starting condition and my front is also going to be my stopping condition. So this gives me the power to first explore my front, increment my index, and check if I've reached back at my front index. Now, inside my do-while loop, I'm going to copy the elements from my old queue into my new queue, and I'm going to increment my I every time I do so to get to the next empty position in my new queue. Now, the reason my j is not incrementing by a single index like j is equal to j plus 1 is because, remember, my old queue is a circular structure, and in order for me to get the next element, I'm going to have to take that current index, add 1, and mod the nums.length. So that's what I do here to get to my next index. Then I set my front to 0, since the front of my new array or my new queue is going to be at index 0. Now, since my old queue is full, then I know that the number of elements in my old queue is going to be equal to nums.length. So I can simply set my rear equal to nums.length minus 1 to represent the index of the last element in my new queue. Then lastly, I simply have my nums reference variable refer to my new array object temp_array.
If you enjoyed this content, please hit that like and subscribe button. See you in the next video. Hello everyone, so we're going to implement a
Okay, that's about circular queue. So okay, we're going to move on to the next slide. Yeah, this one is done. Okay, since this is seems a solution to detect empty and full queues. Use the counter to keep track of the total entries in the queue. I mentioned before, right? You use counter count. Empty queue detected when counter is 0. Full queue detected when counter equals to array length. So this one is basically to check so that there won't be any problems that your element which you want to store in the array will be out of space. So your array will always be able to accommodate for element which you want to insert. Okay. Okay, leave one unused vacant location in the array. Another solution is empty queue detected when front index is one location in front of back index. So this is called a wraparound action. Full queue detected when only one vacant array location left. Okay, so you basically trying to detect, you want to prevent a problem of lack of uh, empty space or full queue in your queue. So you put this kind of operation inside your code. Okay, you set your front index and back index, that it doesn't basically just now when you're watching the video, if your queue basically is empty or was it full, then both your front and the back basically going to be set to -1. Okay, so that is where you manipulate your queue size. This allows us to distinguish between empty and full queue. Yeah, like the one here, one until A until C. For here, this is an empty queue, and then you have one slot front index, a 7 location circular array that contains at most 6 entries of a queue. Okay, so this one is right from the empty, fill up from the 1 until, where am I? Okay, I discontinued something. Yeah, okay. Okay, now right from here, B, it goes to fill up your front index. So front index is set at 0, your back index is set to 0, and then after that, you move on to C, where you fill up one by one, and then therefore your front index is still set to 0, your back index is 5. Okay, and then D is your front index is set to 1 because the queue is moving towards trying to empty a queue, D queue, NQ, yeah? So then it moves towards 1. And then your front will become 1, your back index will be 5. So same goes with that. If you want to move again, you want to fill up the queue, then therefore your front index becomes 1, your back index as it moves along becomes 6. All right, so this is a circular array. This is the operation is empty method. The queue is empty if back index plus 1, and then your array length would be equivalent to front index. All right, so all queue is full. Queue has a larger capacity. This one you saw in the video that if you have old queue and the new queue, so you have basically smaller for your old queue, and then you want to expand it, then there is just simply transfer whatever you have in your old queue go into your new queue, which has a larger capacity. Because now that you have double array, so you double up on your size, so you keep your transfer your elements into the new queue once you set double array in a circular queue. Okay, so this is how it works, like similar to the one which is illustrated in the video. Self recap. So based on your slides, there should you have been briefed and exposed to the 3 array implementation, which is of linear array with fixed front, dynamic front, and a circular array. Okay, so these are the sample codes that we have. Yeah. Yeah, so many codes, sample codes that you can refer to. This is on abstract data type, this is on the entity, and this is on the client or sample on the queue. So next topic is on iterators. Iterators is one of the questions that you're going to be asked probably if you have practical questions. Some of the questions which trains or tests you on whether you understand would be on iterator for this chapter. Yeah, so let's just watch this short analogy on how iterator or iterator works.
In this video, let me tell you a story of an old man in a village, and before you know it, you'll understand what the iterator pattern is in software. Let's check it out. Once upon a time, in a village, there lived an old man who worked in a provision store. His job was to receive deliveries from the farms and sell those food provisions to the villagers in the village. Every week, the farmers would deliver the provisions to this old man's shop, and on the next day, all the villagers would line up in front of the shop to buy those provisions. So this old man has been doing this for many years, and he had the system. He had a logbook to record who got the provisions, how much they paid them, and all that stuff. So when the provisions were available, the old man needed all the villagers to line up one behind the other in front of the store to get those provisions. And that was a problem. The old man's system meant that all the villagers had to stand in line for hours and hours for their food and rations. This was usually a long line of people standing out in the sun while the old man slowly received each customer, wrote down his records in the register. They had to enter the office one by one to gather the provisions because that's how his system worked. But they could do that only after waiting in line for hours. It was hard, especially for the older folks. So the villagers begged the old man to come up with a different way for them to buy provisions, but the old man didn't want to hear any of it. He kept saying, "This is my system. This is how I've been doing this for years, and I don't want to change it." The people wished there was someone who could help them. So there happened to be this village boy who worked as an assistant to the old man. His job was to help the old man as well as kind of manage the line of villagers outside the shop. He would see the people of the village stand in line for hours and struggle. So he wanted to do something to help them, while at the same time not having the old man change anything in the way he has been operating for so many years. He could very easily devise a system where the village folks could stay at home until it was their turn to gather the provisions, some kind of a token system or something like that. But how would he implement something like this without the old man having to change anything, or preferably even knowing anything about it? One day, he came up with an idea. He went to the old man and said, well, you know how we are taking on so much work managing this big queue of village people? I was thinking I can actually make it easy for you. I have an idea. Would you like to hear it? The old man, while rigid, was also usually nice to the boy. So he said, well, sure, as long as it doesn't change my system. And the boy said, yeah, it's not going to change your system. So here's the idea. How about you just sit in your shop and have me let people in one by one? I know you would like your customers in one after another without any gaps. So you just take your time, and whenever you're ready, you just say next, and I'll take care of bringing in the next person in the queue for you. Would you like that? The old man thought about it and felt it was a great idea. So he agrees and said, sure, let's do that from now on. So the next day, the boy had people stand in line as usual. And when the old man yelled next from inside the shop, the boy had the person at the top of the line walk in. And whenever he was done and ready for the next person, the old man would yell next again, and the boy would let the next person in the queue, and so on. After doing this for a couple of days and making sure that the old man was happy and it was working fine, the boy gets all of the villagers together and he tells them his plan. They plan together a number-based token system so that everyone can stay at home except for when it's kind of close to their turn. The plan was settled and put into action the next day. The old man, just like any other day, shouts next when he's ready for the next person. And the boy with the villagers managed to make sure that there is one person walking in when the next call is made. The old man still continues to use the system for recording and serving his customers, but the boy has quietly changed the entire implementation of the system without the old man knowing any of the details. In fact, the contract that the boy has with the old man is so brilliant that the villagers can constantly optimize their system for their convenience. As long as the boy can bring the next person in when the old man yells next, the old man's existing system still works, and he won't even know the difference. What the boy and the villagers have come up with is what's referred to in computer science as the iterator pattern. You see the iterator pattern in action in various languages and frameworks, including Java and JavaScript. For example, in Java, we have various different types of collections that we need to deal with in programming. Some collections, like arrays and lists, are sequential. There's an order to them. And there are some other collections, like sets, which may not have a specific order to them. This is great, of course, because you want to choose the right data structure for the job. But what happens when you need to loop through every item in a given collection? Well, for arrays and lists, you need to loop in one way. With sets, you need to loop in another way. For another collection type, it's something else. That's not ideal. Could there be a standard way to iterate over all the elements in a collection without having to worry about how the elements in the collection are stored or retrieved or managed? Well, you guessed it right. You can do that using the iterator pattern. Every different type of collection can come up with a special iterator object. The job of the iterator object is to just have a method that gives you the next object in the collection. It's basically the boy telling the old man, hey, don't worry about the underlying implementation of the collection. All you need at any point of time is just the next element, yeah? So all you need to do to iterate over this collection is just the ability to get the next element, and that's it. That's all you need at any point of time, the next element. So the array list has an iterator that knows how to return the next element in the array list. The set has its own iterator that knows how to get the next element in a set. The person calling the iterator doesn't have to care or know what the underlying implementation is. If you write code that uses the iterator, you can use that code to iterate on a collection irrespective of the internal implementation of the collection. JavaScript also has an iterator, which is again an object with the next method on it. You can create custom implementations of the iterator that return the next element when the next method is called, whatever that next element happens to be for that particular use case. So this is the basic idea behind the iterator pattern. One last thing you should know is that the iterator pattern also has the ability to signal when the collection is done. What if somebody keeps calling next? The iterator needs some way of communicating when there are no more items left. This is done in different ways in different programming languages. The Java iterator has a hasNext method that returns false only when the collection is empty and it's done with all the elements. Some other implementations of the iterator pattern, like for example JavaScript, returns a done flag, a property on the returned item, which when it's returning the last element of the collection, the done property will be set to true. However this is implemented, basically it's just a way to tell the caller somehow that they don't need to keep calling next for eternity and say, well, this is done now. Okay, so now that the villagers have solved the provisions problem with the iterator pattern, and now that you know what the iterator pattern is, I suggest you check out this next video explaining another popular pattern called dependency injection. It's a very commonly used pattern in programming, especially enterprise software programming. So check out this video where I explain with clear examples what the pattern is.
Okay, can you understand iterator? Iterator? Can you understand the concept?
Yeah.
This is basically you have a set of collections of objects. You do not want to call it one by one, so you group it all together and then you can call it at one time. So there is a process of transferring one after another. So this is iterator. Okay, so let's see your next slide. I have another one video which illustrate the codes for iterator, but that would be in a second. Yeah, let's see.
In this video, let me tell you.
Let's see the next one. Okay, point base. Point base is this iterator. It's an object that enables you to traverse, to go through a collection of data beginning with the first entry one by one, and then pushing it to be executed like a cursor or pointer, moving about on a data structure and locating individual elements for access. Okay, you just like when you go for your search engine, you want to search for one data, you go to a database which consists of a collection of data. So you basically take control of all those collection and share out all the answers or whatever that is needed to be retrieved one by one. Okay, by acting like a cursor or a pointer, moving about on data structure and location of each of the individual element for access. Okay, it's also a software design pattern that abstracts the process of scanning through. Abstract means you conceal, you encapsulate, you basically hide the process of scanning through a collection of elements. So that a user doesn't really know what is happening in there because it is encapsulated, hidden. Okay, so this is the work of iterator. So this one is iterator. You can go back, forth, previous, next. Yeah, you can also locate in the exact location of the element of data inside your array. During one complete iteration, each entry is considered once. Iterator may be manipulated, check whether the next entry exists, ask to advance to next entry, give reference to current entry, modify the list to traverse it. Okay, this is the basically benefits and the functions of iterator. Now this one is the video which I got, which explain and show you example of codes on how you actually put in your or use iterator in your codes. Okay, so we will just quickly watch on this one so you can have an idea on where and how you embed that in your code. I don't know whether you have encountered this in your code or you have added your iterator, but this one is also a way or shorter way to actually execute. If you remember a place where you code somewhere, case, I think you have done this in your project or object oriented, the case call, case 1, case 2. selection. Yeah, so if you have that, this one is probably a shorter version of calling each of the case, if you remember. Okay, but okay, let's watch this.
Welcome to part 17 of my design patterns video tutorial. Today we're going to talk about the iterator design pattern. So what exactly is the iterator design pattern? Well, this pattern is going to provide you with a uniform way to access different types of collections of objects. So for example, if you get an array list, and a hash table that are all full of the same type of objects, you could pop out an iterator for each and treat them the same. What this does for you is provides a uniform way to cycle through all of these different types of collections. And on top of that, you're also going to be able to write polymorphic code because you can refer to each collection of objects in the same way because they are going to implement the same interface. Now, if that sounds confusing, don't worry about it. I think this is 100% understandable if you just watch an example. So what I'm going to do is just jump directly right into the code. Okay, so here we are. So in this situation, I'm going to use a kind of real world example. Let's say you wanted to get information from the top 70s, the top 80s, and the top 90s disc jockeys, people that play music on the radio. And as a programmer, what you tell them is you want them to provide you with an object, and each one of those objects is going to be based off of song info, which means they're going to give you a song name, a band name, and the year that it was released. On top of that, now that they know this is the object they have to use, you tell them that they all must use a function named add song for adding both the song, the band, and the release. And on top of that, they have to use a function called get best songs that will return the collection of songs. The one thing you forgot to tell them is to use the same collection. So in this situation, the DJ from the 70s is going to send you an array list. From the 80s is going to send you an array of these objects. And then the guy from the 90s is going to send you a hash table. Now, what you could do, of course, is say, no, wait a minute, I forgot to tell you, I want all of these to be of the same type. But being a programmer, you're just going to make things work. So here we go. Here is the song info class. And all of the code is available underneath the video. And if you want to 100% understand this stuff, you should go get it. So let's just jump right into it. First thing we're going to do here is go to songs of the 70s, and we're going to look at the type of information that we could be expecting from somebody like this. All right, so they're going to send us Java util, and this guy's going to send us an array list. So we're going to need that. And a little bit later on, we're going to need the iterator library, so we might as well just put it in here right now. So there we are. Okay, and then we're going to create our class. So this is going to be public class, songs of the 70s. Then we're just going to come in here and create an array list, and it's going to contain song info objects, just like we told them, and it's going to be called best songs. Course, make that capital. All right, now that we have that, we're going to create a constructor for this guy. Songs of the 70s, this, and we're going to go best songs. And what I'm going to do the first time is show you the problem and show you how to force it to work in the wrong way or in a bad way, actually in a very obvious way. And then I'm going to show you how to use the iterator design pattern to do it in a much neater way. So we told them add song needed to be used, and these songs are just purely copied, so it doesn't have anything to do with my musical taste. It's just what popped up on a website. So don't attack me if you don't like these songs. I'm going to have the add song method, which I'm going to create here in a second, and then we're going to add another song and a final song. So there you go. We're creating the array list, and we're adding the song information to this guy inside of the constructor. So what do we have to do now? And this is what you're going to be receiving. So we'll go public, and you're going to be forced to work with it in a good way. So we need to actually come in here and allow them to call the add song method, song name, string, band name, int, year released. So there's all that information that's going to be sent to this guy. And then we're going to have to come in here and go song info is going to be equal to new song info. Song name is going to be passed, band name, and year released. So that's going to create our song info object. And then to the array list, we're going to call add song info. So each time this is called up here, add song, then this is going to be called down here, and then put int there. Then we're going to do this in kind of the wrong way. And like I said, I'm going to show you how to do it in the obvious way, and then I'm going to show you how to do it in a less obvious but a much nicer way. So this is going to return an array list of type song info, and best songs is going to return the array list. So just return best songs, and that's all we need to do. So it's not messy by any means. It's actually good code, but we have to figure out how to use it for our own situation. So I'm just going to copy that, and then I'm going to go into songs of the 80s, bounce in here, paste that in there, and then we're just going to need to change this to the 80s and this to the 80s. And then this guy's going to send us an array list, or an array that's going to have song info items inside of it. I'm going to leave all the rest of that the same. And then this guy right here is going to need to be changed into a song info array. And I'm going to call it best songs as well. And then I'm going to put an integer inside of here that's going to allow us to increment to the next position in our array. So I'm just going to give that a value of 0 in the beginning. Best songs right here. I'm just going to get rid of this part and go song info and say this needs to be 3 in length. And then all of this is going to remain pretty much the same. I'm just going to change the band names here real quick. And there we go. Now we got some new band names inside of there. And then I need to add the song info objects to an array and then increment to the next position. So this guy right here is going to remain exactly the same, but this guy here is not. We're going to instead go best songs and then go array value. See, that's what we're doing there in regards to incrementing that. And then we're going to add a song object to that and then go array out value, write that, and increment it. So that's pretty cool. And then down here, of course, now we're going to be returning an array full of song info objects. So we just need to change that, and everything else is fine. So we don't need to change anything else. And we can just come in here and copy that. And now we're going to go into songs of the 90s, paste that inside of there. And then for songs of the 90s, this guy's going to be sending me a hash table. So we need to get the hash table library there. I'll leave everything else the same. Come in here. These guys are going to change because we're going to be holding a hash table that's going to have an integer object inside of there as the key, and then song info as the actual value. And I'm going to call it best songs, just like before, is equal to new, and then it's going to be hash table exactly the same here as we have on the left side, except we're going to go like this and like that. So that's going to create our hash table for us. And then we're also going to increment the hash key here, and I'm going to give it an initial value of 0. So we're going to increment it in much the same way that we were incrementing the array. And then of course we need to change this to songs of the 90s and song of the 90s, just like that. We're not going to need to initialize anything because we already did that, so that's good. And then I'm just going to throw in some more songs, and there we are. There's 3 additional songs. And then down inside of here, we're going to get rid of this guy right here, and we're going to type in, actually I just need to knock off the end. I'm going to call put, which is going to ask for a hash key, and then it's going to ask for the object that's going to go inside of there. Get rid of that, and then I just need to increment my hash key. And then of course down here we're going to be returning this hash key right here, so I'm just going to copy it, and there you are. And then we're going to save it. So now we got songs of the 70s, 80s, and 90s. So let's go and let's actually take a look at exactly how these are going to work. And I'm going to do that in a class called diskjockey.java. It's going to handle putting all this stuff together. So I'm going to need to get a whole bunch of different libraries in here. Till array list and enumeration and hash table, of course. And the code I'm going to show you here in a second, it definitely works. It's just not neat. And it's obviously not using the iterator design pattern. And then public class, diskjockey, and then it's going to go songs of the 70s, and then I'm just going to call this songs 70s, and then I have to do exactly the same thing for our other 2 classes, which is the only thing's different here is the 80s and 90s. And then I'm going to go public diskjockey, create this constructor here, and then it's going to get past all of these values. So let's bounce in there, paste that in there, change that to that, change that to that, and then I'm just going to call this new, which doesn't matter. I just like to do it that way. There we are. And then, of course, take that there. And then this is going to be really simple. We're we're just going to go songs of the 70s, 80s, and 90s. Paste that in there. And then we're just going to go equals like that. Actually, makes it a lot simpler just to copy that. Paste that 3 times and then change this to 80s and 90s. So we're just assigning those objects that are being passed over into our own special place inside of our class. So I guess to a certain extent, this is kind of a review of using collections. So now we need to implement a method, public void show the songs. And I'm going to show you how you would iterate through all these different types of classes if you didn't know about the iterator design pattern. Because all of the song info objects are going to be stored in different collections, everything, of course, needs to be handled on an individual basis, which is terrible, but that's what's going to happen. So I'm just going to call this AL 70s songs. That's an array list, songs 70s dot, and then I'm just going to call get best songs. Okay, so we got our array list with all our songs in it. Then I'm going to go system out, print line, and I'm going to say songs of the 70s, and then throw a new line in there on top of that, just for the heck of it. And then what do I need to do? Well, I'm going to create a for loop here. I is equal to 0 while I is less than. Going to get this array list that we just saved everything to and call size on this. Since it's an array list, we need to get the length of the total number of objects in the array list like that. And then we're going to cycle through all these. And the first thing we're going to do is go song info best songs, and then we're going to song list. We need to cast this to a song list object, array list 70s songs get, and then we have to tell it what index to get, that's the reason why we have the for loop. Oops, this is actually song info. Remember, we're using this song info class that we looked at earlier, this guy. All right, so now that we have that, we're just gonna have to print out the name of the song and the name of the band and all this other different stuff. So we just need to go best songs and go get song name, which is saved over in that class. And then we're just going to copy this. And then instead of get song name, we're going to go get band name. And then here, get release year. So there we go. So pretty easy. Giving me a little bit of an error. Let's see why. Get year released. Okay. So let's just go year released. And then jump back over into disc jockey and type in year released. And there we are. So there we go. This is going to work perfectly fine for our array list that is full of song info objects. So now we also, this is the pain in the butt part. So you're never going to do this after this tutorial. Now we need to do a similar thing, except this time we're going to do it with an array. This is no longer an array list. It's going to be song info like that. And I'm just going to call this array 80 songs. Change this to 80s. Get best songs. All that's going to work still. Change this to 80s. And then this guy, we're going to be going through an array now. So paste that in there. And then this time we're going to call length because that's what you do with an array. And then down here, we're going to leave this song info, best songs, except this is going to be this guy right here. So let's just copy that, paste that there. And then this is going to be I. So we got all that. And then everything else needs to say exactly the same. So in general, it's good code. It's just, this is too much. So then we got to do the same exact thing for hash tables. And we shall. So paste that in there. Now you're going to see how to cycle through hash tables with objects in them. So what are we going to do? We're going to, first off, we're going to jump over to songs of the 90s. And we're going to copy this because I don't feel like typing all that out again. And then jump back over into disc jockey. And then this is going to be that very specific type of hash table. And then here, we're going to call this HT 90 songs. And everything else is going to be the same on that line. See? Good code, just messy. This is going to be changed to songs of the 90s. And then the for loop down here, instead of using this stuff, we're going to use an enumeration that's going to hold our keys for us. So remember, we were using integers. And I'm just going to call this E is equal to HT 90s songs. And then we're going to go key. Then I'm going to go E. So while I have more elements in this hash table, I want to continue this looping. So that's all that's going on there. This is going to stay the same, except, and we're going to go HT 90 songs, paste this in there, and then we're going to go call get, and then E, we have to give it our key, which next element is going to have the value for our key, and then everything else can be exactly the same. So there we go. It's kind of long-winded, but it's still good code, so you can't really complain. So now let's file save that, and I'll show you how all this is going to work. I'm going to go into radiostation.java. And this is going to work very easily. We're going to go public class, radio station, and then we're going to go public static void main string. There's that. Args. And then I'm going to go songs of the 70s. Songs 70s is equal to new songs of the 70s. So we're going to create this object here, right like that. So very simple, still pretty neat. And then we're going to do exactly the same thing for songs of the 80s as well as the 90s. And there, and there. There we are. And now if we want to call these, we're going to go disc jockey. And we're going to say our disc jockey has the name Mad Mike. We're going to go new disc jockey. And we're going to send him over songs of the 70s for him to play. Songs, and this is going to be 80s, and then this is going to be 90s. So pretty simple. And then to get Mad Mike to play these guys, we're going to go Mad Mike, show the songs. And if we did everything right and we run this, it shall work. And there you can see it did. Okay, see it prints out songs of the 70s, and then you get Imagine, John Lennon, American Pie, blah, 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 blah. Songs of the 80s and Rome and all these other different things, and songs of the 90s. So, hey, it works. So why complain about it? Well, the reason why is it's possible to make it work that much better. It's really the difference between being a great programmer and an okay programmer. And how we're going to make this work beautifully is we're going to create ourselves a new interface, and it's going to be called songiterator.java. This is going to allow me to refer to everything as a song iterator. Every single one of these previous classes that we created will now be referred to as one. So the first thing we need to do, of course, is import our Java iterator library. And then we're going to go public interface song iterator, and then we're going to go public iterator. This is going to be the class that has to be created, and it's going to be called create iterator. Not much work to put into creating something that's going to make everything really, really cool. So let's file save that, and then to make all this work, we're going to jump into songs of the 70s.java, and we just need to go implements song iterator, right like that, and then it's going to give us an error message. Songs of the 70s is going to say, hey, you need to bring in some unimplemented methods, and we shall click on that. Then we need to scroll down right here, and we need to just pop out an iterator that's going to make it easier to use this guy. And before we do that, we can come in here and say, hey, we don't need this anymore, which is a mess. We don't want them to send back an array list because that's not neat and that's not good coding. So there, that's gone. And then come in here to public iterator, and then what it's going to do is return an iterator here. It's going to allow us to easily bounce through everything we got here, and we're going to go return best songs. And what's best songs? Best songs, you see it everywhere. This is the array list. See, best songs, this is the array list. And then all we need to do is, instead of bouncing back an array list, we need to bounce back an iterator. And you do that just by doing that. And there we are. Well, we did a lot. Okay, pretty cool. So now we need to do the same thing with songs of the 80s.java. So we're going to come in here and go implements song iterator. See, another thing that's great about this is we're not changing that much code. Always a good thing. Come in here, add unimplemented methods, bounce down to the bottom of the screen, come in here. Remember where we're sending back an array? Well, we don't want to do that. Instead, we want to send an iterator, and there we are. So got rid of that. Get rid of this if you want. And then down here, instead of sending back an array like we were doing before, we're instead going to send back an iterator, of course. And to do that, we go arrays as list, and then send it best songs, which is the name of our array inside of here, and then call it iterator like that. And there we are. Now it's an iterator, and now at least it's sending back an iterator. So let's save that. Now let's go fix songs of the 90s. See how easy this is? And then what are we going to do? We're going to go implements song iterator like that. File save it, and it's going to say, hey, you need to implement some stuff. No problem. Go implement that. Scroll down. Okay, we don't want to return a hash table anymore because that's not good, and let's get rid of that. Of course, you delete it normally. And then down here, now we need to send back an iterator for the hash table instead of a hash table. And to do that, we're just going to come in here and go best songs, which is the name of my hash table. Type in values like that, dot iterator. I'll save. There you are, done. So now what's left to do? Since that was so simple, well, of course, we need to go into discjockey.java and save or change everything we got here. So now instead of passing this stuff here, we're going to create song iterator. See, we're going to refer to everything that implements the song iterator interface as a song interface. See, we're able to refer to everything as if it's the same thing. Always a good thing. So we're going to refer to it as a song iterator, and I'm just going to call this iter 70s songs. Okay, got that set up. Copy. And then here we're going to go 80s and we're going to go 90s. See, we can refer to everything now as a iterator, which is always great. And then we need to get rid of this guy altogether. So let's just delete it. The disc jockey, or better yet, let's just change this from songs of the 70s to song iterator. So copy song iterator like that. And this is going to be song iterator. And this is going to be song iterator. There that goes. I'm going to leave everything else have the same name. And then song 70s is going to be new song 70s. And then we're going to need to change song 70s to iter 70s right there. So this is an interface. And then this is going to be the interface that's going to represent the 80s. And this is going to be the interface that represents the 90s. So there we are. Now we got that set. And then I'm just going to skip this whole thing, show the songs. So let's just leave that there in the code so that you can look at it later and see the way not to do this. And now what I'm going to do is treat everything as an iterator. So we're going to go public void, and I'm going to call this show the songs 2 just for brevity. And then I'm going to go iterator songs 70s is equal to iterator 70s songs and call create iterator like that. Pretty simple. Copy that. Now we need to do the same thing for the 80s and the 90s. 80s, 90s. There we are. Done. So now we have those all set up. And watch how easy it is to now print everything out properly. Print line. And I'm going to go songs of the 70s. Throw in a new line. And then to print out, print the songs, which I'm going to create here in a half a second. Songs 70s, right like this. Change that to uppercase. And actually, I'm going to do it right now, just so you can see it here all on one screen. We're going to go public void, print the songs, and it's going to get an iterator sent to it. Iterator, like that. And then we're going to go while. See, we're going to be able to treat every one of these, even though they're different collection types, as if they're one. So as long as we have more elements in our iterator, we're going to print out information. So look at this. I can just copy this. Copy. Now instead of doing that 3 times, I only have to do it 1 time. So like this, and go song info, and I'm just going to call this song info is equal to iterator next, like that. And it's going to tell me I need to cast it, which I'm just going to click on it, say good, cast it into a song info object. And then down here, I just need to change these into song info, paste, paste, and paste. So file save. And then we need to jump over into radio station now that the disc jockey is prepared. And am I going to have to do a whole bunch of changes here to make this work, even though it's so much cleaner? Nope, just that. I just changed that to show the songs too, and then I'm going to execute it. And you can see it pops up, songs of the 70s, and there is Imagine American Pie, da-da-da-da. And you may say, well, where's the rest of them? Well, the reason they're either not there is, I don't know if you remember, but I didn't create them. So if I want to print out the 80s and 90s, no problem. Let's go like this, change that to 80s, change that to 90s, change that to 80s, change that to 90s. File save. Don't need to change this at all now. Jump back over into radiostation.java, and there you see, print out all of those. There's songs of the 70s, songs of the 80s, and songs of the 90s. So there you go. That is how to use the iterator design pattern. It's a little bit to wrap your head around, but remember, if our ultimate goal is to be a great programmer rather than an okay programmer, study this stuff and understand it, and you'll get there. Leave any questions or comments below.
Okay, did you see that? Excellent, isn't it? So that can be implemented by into your code for your assignment. So I got an idea for you, Noel and Calvin, right? You can follow exactly the same way how you do the iterator. That would be much easier to, rather than you just copy everything, right? So that is enabling you to call all sorts of collection in one particular space and then call out everything at one time without having to copy so much of the program, like how he actually basically commented so that you cannot no longer need access codes. You need only a little bit of codes in there, right? Okay, so that is Java iterator interface. Okay, so I think we're gonna finish up with this one. We're gonna go for our practical, another hour, 1 hour. Okay, so that is that. This one is just extra I put in for you to differentiate between iterator and list iterator. Read on that one, yeah? The simple information. What is iterator and list iterator? Read on that one. And then this is your Java utility iterator. And then hash next, next, remove. All this are in your Java utility iterator. Other than that, let's just go through here, the last part. The coding which it shows there. I think the video is pretty thorough to show you what is the function for your iterator, which you call Java utility iterator. As next, boolean, and then where you basically check whether the list is empty and all that. So by using boolean and whatnot, here is your example in the class iterator. But I think the one which you saw in the video is also very clear. Okay, just refer on this one for your own reading. Okay, so sample code, again, there are a lot of here that needs to be attached for you. Okay, so I will slowly attach once our session is over within this week. Okay, so you should be able by now to implement the ADTs list, stack, and queue and arrays a little bit or so because it is very compact today. So many to absorb, discuss the strengths and weaknesses of using arrays to implement the ADTs, analyze the efficiency of the array implementation of the ADTs. Okay, so don't get discouraged if you see too many codes. Just slowly absorb and learn about it. Okay, all right. Okay.
Okay.
So, yeah, done with this one. We go to your practical. So this one is your pre-practical question. Hang on. Pre-practical question is this one. Meaning this is for your review, for your self-review. Usually when you when you actually look at the question, you should be able to answer all this question. Yeah. Okay. Not this one. All right. Hang on. Practical question is this one actually. Wait, hang on a second. First, we need to look at your practical question first. Yeah. Okay, where are you at now in here? Have you done with your palindrome?
Yeah.
Done with your palindrome? Palindrome done?
Yeah.
Yeah, okay. So I have the submission box there in the Google Classroom. Okay, and now you look at, hang on, this is assignment. Yeah, here, palindrome. So what about number 6? Number 6, okay? Is it okay, this one? All your codes, right? What is the problem? Do you have any problem with this one?
Yeah, I don't know how to run it.
Oh yeah, cannot run the post office sim.
Which one? Cannot run this?
Yeah.
Yeah.
Huh. The class post office sim Java simulates a post office single queue multi-counter environment. What was the problem? I mean, like, what was the error messages? It says just cannot run. I think, hang on, maybe you have missing. missing code. Both methods of class post office. What was the error messages like? Can you run it now? Can I see?
Wait, still opening.
Yeah. I need to see what is the problem, because otherwise I know should be able to. Question is saying that the class post office sim Java simulates a post office single queue multi-counter environment whereby customers take number and then the turn comes their number and servicing counter will be announced. So you should have your customer the Java post office sim, and then this is your GUI. If you cannot run that, maybe you have a missing image, I think, right? Missing image. Complete the following. Hang on, let me see what happened. Whether I have missed out giving you details of your code. Sample code. Post office sim. Which chapter is this? Chapter 4, is it? That is customer?
Oh yeah, this is the customer file, but the form, I have no idea how to run it. Actually, I received another file from my friend.
Yeah.
It appeared to be like this. This is my friend's
that's
file.
what I said. You don't have that. Let me see. I probably missed out on giving you that. Hang on. So when you added that post office sim 1, did you manage to?
Initially, yeah, but
This one?
there's something. Yeah,
Okay,
I
okay.
think.
Hang on, okay. Chapter 4, right? Let me see. Message that file for you, yeah. So basically, you can display this. Did you manage to? Okay. What happened? Did you manage to add? I think the code is not complete. You have to actually add something to the code to enable it to work, some function or logic arithmetic function that you have to add in. Example, this is a service. Average time is. You haven't set the data, right?
I think this is yeah, my friend. I think he already completed maybe lah.
Really?
I haven't checked. I haven't checked it.
Yeah, if you have there should be a number, okay?
1
So
0
yeah, the
0
customer take
1
the number,
counter
then
1
staff click on this, then so the customer go to counter 1, then another customer take another number. So let's say it's counter 3.
1 0 0 2 counter 3
Then it shows here. If I click this analysis report, yeah, it's an error. So yeah, it's incomplete. It's the only thing.
Format argument exception. You did not state that in your code. Yeah, because that is to check if true or not. Remember, you have this exception throwing and you call it exception.
Oh,
missing.
okay.
So there's a missing form argument exception. Any queue, yeah, you have to set that one, right? This one is your friend's post office one?
Yeah. He previously he also takes this subject data structure.
So this one is the one that is working.
Not sure. I think because based on just now, this one got the error, right? So
Okay,
I
hang on.
think
You need to see the question again. What is the question once? Yeah, wait, hang on a sec. Yeah,
okay.
let's check the question first. Check the question. Question says complete. Hang on, let's see, what is it? For this question, you will need to use the following Java classes in Chapter 1. It means Project Post Office folder, which is your customer Java post office sim.java. The class post office sim. The Java simulates a post office single queue multi-counter environment whereby customer take a number. And when their turn comes, the number and the serving counter will be announced. So that would be in your figure 1.3 with the GUI that you have shown a while ago, right? So you have counter 1, 2, 3, 4, 5. So you need to keep taking the number in order to display, isn't it? So complete the following methods for the class post office sim. The event handler for the take a number button. The text area below this button should then display your number with the automatically generated next sequence number. Counter listeners action perform method, you have that, to be executed when any of the counter N buttons are clicked. Ensure that the text field in the first row under the customer UI section will list the next number to be serviced and assign counter number. All the remaining text fields below the top row will be updated accordingly. Okay, announce the sequence. Did it manage to update accordingly? If you keep taking the number, okay, and then you say if you press there, I think it should be automatically, right? Let me see, what is that? Yeah, automatically generated next sequence number. Okay,
Yeah, I think
and
it's
then
done.
hang on, let's see. And then you take number, and then after that, what happened? You click on the counter.
I click now.
Press this button to get a number, yeah. Okay, then how does that get displayed on counter number 1? You should click on that one, is it? Stop UI. Oh yeah,
Yeah.
okay. So click on that.
One
Then that
zero
display,
zero one
not
counter
displaying.
one.
Display.
Okay. Okay, and then after that you take another number.
So it's one to the
And then you should click on that counter number 2.
1002 counter 2.
Hmm. Hmm. What happened? Hang on. The first 1001 should be in counter number 1, right? So 1002 should be in counter number 2, isn't it? Oh yeah, okay. Okay. So then after that you take another number, so it should be able to do the same thing, right? Yeah, okay. You do the all of it? Do all of the counter? Just do the all counter?
1003 counter 3. 1004 counter 4. 1005 counter 5.
yeah, it works.
Okay, and then everything is updated. What about your analysis report?
There's an arrow.
That is the problem. Hang on. Post office report perform. Access 100. Action received. I think you have one component missing. Yeah, your missing format argument exception handling. But if your friend able to display the report, then it should not be missing this one unless you copied it wrongly or you missed out a form or something. But this one is the Java utility missing. Where's your Java utility? Missing format argument exception, format specifier, percent 20, X. Okay, wait, let me see my document.
Okay.
Which question is that? Question number?
C. C.
C, what number? One, 1C?
6. Question.
Six, okay.
1 0 0 1 counter 1 1 0 0 2 counter 2 1 0 3 counter 3
Hang on, let me check my file, yeah?
Okay.
Oh, I just received news from our program leader. It seems that because of the rising COVID cases now in KK, Sabah, our Sabah branch management has decided to basically extend our online teaching until end of February. So next week will not be online. Next week there will be no face-to-face. We are still going online until the end of February.
Okay.
Okay. So yeah, so you don't have to go to campus next week, just for online for now. So this will be reviewed again for March onwards, depending on the situation. Okay. Okay. All right. Let me continue for searching for my file. See what's problem with yours. Gonna. Oh, okay. I forgot to give you one, which is the post office form. So hang on. Let me attach that in your coursework, yeah? I think you're
Yeah.
missing that. Yeah, hang on. What did I give you? Postoffice.java or postoffice.form? .form.
From
I think I deleted or something. You got that, not that .form, right? You got that one .java, right?
yeah.
The file which you're doing right now, is it .java? Postoffice.form.
Yeah,
You're doing
job. Oh, yeah.
that is yours, right? That is not from me, right?
From my friend, yeah.
Yeah. So where is yours? Yours is a postoffice.form, right?
This one.
That means I missed out on the Java. Hang on.
Oh.
The Java is missing. Hang on a second.
1001 counter 1102 counter 3
Okay, hang on. I will attach that form. I think your problem is that this is not you. You are missing with that .java. That's why you cannot run. So you are mixing the argument format exception. Okay, so hang on. I will give you that. But in the meantime, I need to ask the question: did you guys do already that practical part 3, which is under which one is that? Which is under part 3, right? Which we skip and then we go for efficiency of algorithm.
Oh,
No,
haven't
sorry,
started.
Not.
No,
not yet,
no.
not yet, right? Okay, so never mind. You continue. You guys continue with this. Um, mm, you continue with that. I will give you the questions when you are done with what you are doing, because I don't want to um, you put you so much load on this one, because you still need to do your assignment, right? So I want you to finish up with this one first. Let me find the file and then see if you can add that in and then run it. If it is is working, then I add another practical question for today. Yes. Otherwise, I will wait for you to complete with that one. Okay, but I will always give you time to complete the practical questions when I assign to you. Maybe one question for today. Okay, but you don't worry about that. I give you 2 weeks to complete each practical session. In the meantime, pay attention also to your assignment. Yeah, your assignment is very important. You have to see that you fulfill on track with the schedule. Hang on, let's see. Where is your cost plan? you need to be on track with schedule, yeah? You don't miss out on that. Schedule for this because your assignment is very crucial. Cost plan. I need to see the cost plan. Where's the cost plan? Where is that? We go here. Wait a second. Just let's look at your cost plan first. Practical material cost assignment. You have your assignment question, assignment plan. Wait, we retrieve that. This is under data structure, cost plan. Today is week 4. You're still under array-based implementation ADTs, so it isn't not to worry. You still can do your practical for that. Okay, we're still on track. So you continue with that. I will give you the necessary missing file, and then you tell me after this if you still unable to do that. Yeah, we check your code. What's wrong with it?
Okay.
Okay. Okay. So adjustment assignment specs. Yeah. So make sure you understand this clearly. Your assignment spec. Yeah. If you have any questions about that, I have already received the form. Because the course leader says that you you need to submit one for me, the copy, because the one that you fill up the other day was for KL. Okay, so never mind. You go on with these practical questions which you need to complete it. Okay, if you have problems to submit that within the timeline which I have given you, do notify me before the due date so I can extend another week. Okay, and then in the meantime, I want you to also tell me and update me what have you done for your assignment. Okay, what is your progress? At least you do analysis on what are the kind of modules you have already planned. All right, so Noel is doing karaoke, right? And then Calvin is doing group buying. Yes. So module that you chose. What is the module that you chose? You have chosen maintenance, is it?
Me?
Yours is maintenance.
Yeah, some maintenance. Yeah.
Hang on. Where is that thing? You have the coursework maintenance. And then Calvin is doing also maintenance, I believe. Yes, Calvin?
Yeah.
Yeah. So make sure that you guys knowing what is it that you need to put down in your maintenance, what are the functions that you have. Get ready with it, because before you proceed with the coding, you need to know exactly how it does and what it's doing, right? I need the progress to be um, presented next week, yeah? Apart from your practical questions, we will want to focus on your assignment as well. I need to see what have your progress been. Where have your progress been on this year? I don't want you to be burdened with the practical questions so much. As long as you complete it, you understand it, then it's fine. But most of all, you need to focus as well on your assignment. Okay? You should already started at least one particular stage where you identify what are your codings or modules that how it executes. Okay?
Okay.
Okay, so for today, continue with your practical questions, which I have given you. We are still under this. Get on, finish up with this one, question number 6A, B, C, and then practical question number 3, efficiency of algorithm. If you can finish that within this week, or yeah, I think your, what is your due date? Due date would be week 1, week 2, week 3. That is due 15, February 15 next week, right? If you're unable to extend, I can extend the due date. Let's just do it. Extension. Extension, maybe 20th, another week, or next week. 22nd. Yeah. Okay, so I extended the due date. Continue with that, yeah. Continue with that. If you have problems still after I posted that missing link, do inform me, yeah? Yeah, no?
Posted the link where?
What link? I mean,
Ah.
I'm going to include the missing form in your coursework under Google Classroom.
Okay.
Because I noticed that I gave you form only. You don't have that Java. I believe I posted the Java.
Yeah.
Yeah, I think that's why you cannot run it. Okay. So if I attach that, you try and see if it's working, and then probably you should add the one that you need to add. The one that you need to add inside your code. Okay, so you have your reference from your friend's one. I will give you the one that you should have. All right, so
Okay.
for now, continue doing what you need to do. We will continue again next week for the next chapter. Make sure you revise your note. By the end of this time at this session, I will upload the notes. I will upload the missing file for your practical, and I hope you don't delay on making progress on your assignment as well. Yeah.
Okay.
So next week I'll meet you here as well online until apparently end of February, or until it is announced that we are going to go for face to face, but which is good, right? Don't have to get exposed. A lot of people are getting casual contact for now. Okay, so I'm like my friends and all that, including me. Yeah, so that is quite dangerous to get exposed to other people as well. Okay, so do you have questions before we conclude?
No.
No from Noel. Kelvin?
No.
Do you have any problem, Kelvin, about your practical? The same like Noel?
Yeah, I just cannot run.
Okay, that is because you have missing file. I believe you can run it after that. Okay, but you know you have to add your details, right? Okay, so if there's no questions, we shall meet again next week, Tuesday. I have extended, if you notice, I've extended the time for your submission. Okay, that would be on the week after next week, I think, because today I did not assign you any questions because you have not done it. You did not manage to do it. So you have to pay attention to that one and do that first before we assign you another one. Otherwise, you'll get overloaded. You're already overloaded with all this lecture, right? It's so much to absorb. Okay, so I wish you good luck in doing your progress for your assignment. Complete it, and then any problem at all, you have the WhatsApp and WhatsApp me, tell me your problem, yeah, before our class next week. So we can solve together that problem during practical.
Okay.
All right, so if there's no question with that, thank you for your attendance. I'll see you again next week, and have a great weekend.
Okay. Thank you, Miss.
All right.
One, zero, zero, one. Counter. One. One, zero, zero, two. Counter. Three. One, zero, zero, three. Counter. Five. One, zero, zero, four. Counter. Five.